Is the Earth's North Pole a magnetic North Pole? What happens if the Earth's magnetic field flips? In order to answer this question, we must first understand what is meant by magnetic North Pole and concepts of magnets, magnetic fields, and magnetism. A magnet is a material or object that produces a force that pulls on other magnetic materials. A magnetic field is the invisible area around a magnet that scientists call a field. And magnetism is the physical phenomenon produced by the motion of electric charge, which results in attractive and repulsive forces between objects. Here we can see that two opposite poles are attracted to each other, whereas two of the same poles repel each other.
Alright, so now we're going to be showing the magnetic field of a bar magnet. I've got my gloves on since we're going to be using iron filings and they can be quite sharp. We're using it on a white piece of paper so we can see the colour. And on our bar magnet you can see our north and south pole. So once we start dusting this, we should be able to see the magnetic field start to form. Okay, so what we can see here is that around the poles, the north and south, the iron filings are really starting to bunch and that's where they really are drawn to. But also stemming from the poles we can see these lines, and these are just mapping out the magnetic field around the bar magnet.
Here is a clearest shot of the bar magnet with the magnetic field being mapped out by the iron filings. Back to our question about the North Pole. If we were to use our compass to indicate where north was, would it point to center at the North Pole? Not exactly. Planet Earth has two North Poles. The first is the geographic North Pole, which is the invisible bar that runs through the center of Earth that Earth rotates around. The second is the magnetic North Pole, which in this diagram looks a lot like our bar magnet that we were just looking at. We need to remember that opposites attract. And so when our compasses are pointing north, the north magnet in our compass is actually being attracted to the south pole of the magnet. This makes the North Pole actually the south magnetic pole. Referring back to our last demonstration, we saw how the bar magnet generated a magnetic field. This is a diagram of what it looks like on Earth.
Okay, so now we're going to do a demonstration of the Earth's magnetic field in play with solar radiation coming from the sun. So first up we have our Earth, which is the soccer ball in the center here. And then around it we have hula hoops, which are our magnetic field that protect Earth from solar radiation. And then these little golf ball things are going to be our solar radiation or our charged particles that are being sent from the sun to Earth. Okay, so now we're going to send our solar radiation or our charged particles towards Earth from the sun. And as you can see, the magnetic field has deflected all of the radiation, meaning we don't receive the charged particles. The shape of the magnetic field also results in these sections here around the poles, so the north and the south pole, where particles can travel along the lines of the magnetic field, and this is where they interact with the top layers of Earth's atmosphere, and the particles actually slow down and convert into photons, which is light particles. And that's why in very northern countries like Norway or Canada and very southern areas like southern New Zealand and Tasmania, you see auroras.
Here is a picture of the Aurora Borealis in the Northern Hemisphere, and here is a picture of the Aurora Australis in the Southern Hemisphere. But does Earth's magnetic field offer any other service other than just creating pretty lights in the sky? Yes. It protects us from solar radiation that can cause issues such as skin cancers, disrupting power grids, interference with satellite transmissions that can impact your GPS, mobile phones, and airplane navigation. It's not just us humans that benefit from the magnetic field. Have you ever wondered how sea turtles find their way back to breeding beaches, or how honeybees navigate to find new homes? And it's not just turtles and bees. There are so many animals such as whales and birds that use Earth's magnetic field for navigation. So what happens if the magnetic field flips? Well, for starters, our compasses wouldn't work. It would say that north is in Antarctica and that south is in the Arctic. Animals would also have issues navigating, which could impact breeding and nesting. A flipping of the magnetic field would also considerably weaken the magnetic field. The effects of a weakened magnetic field have already been observed on the South Atlantic anomaly. Satellites that pass over this region face the possibility of frying onboard computers and electronics due to the increased solar radiation. Satellites such as the Hubble Space Telescope actually don't transmit any signals while passing over this region to avoid this. If the magnetic field was to flip, we would see issues like this globally, not just at the South Atlantic anomaly. So, to summarise, Earth has two North Poles. We have the geographic North Pole and the magnetic North Pole. Earth's magnetic North Pole is actually the south pole of Earth's magnet. That's why the north magnets in our compass are attracted to it, because opposites attract. If the magnetic field was to flip, we would see issues on Earth with satellite interference, health issues, just to name a few. And for animals, they would have a lot of trouble navigating, and that would impact breeding and nesting.